Oh yeah, we're back. It's your boy, Big Bot. Time for a little nightly talk about something AI, something in the future. Sometimes we're gonna go off topic and talk philosophy or crypto or something. But let's get back to our roots, okay? We got an article, ingesting millions of PDFs. Why Gemini 2.0 changes everything. I've been trashing Google just because what is it? The Google graveyard. How do you get to the Google graveyard? Are we killed by Google? Exactly. Like I think anyone who's been programming long enough is used to this experience, which is don't ever build anything that don't build off anything Google is doing because they will cancel it and they will rug pull it. And then they are obviously very, very influential in the AI space, writing seminal papers. Like they invented, I always say they put the T in GPT. However, they suck at product, right? That's Google's story. Gemini, I didn't even really care about it. It seems like no one seems to care often what Google's doing because it's always like demos and like a paper and not actually being able to use it. However, maybe this 2.0 is pretty good, okay? I gotta be a little more open-minded. I'm making snap judgments on some stuff, trying stuff out. Even today, I was using deep research by OpenAI. A lot better than my first go at it. It was just being a little too hasty. I'm a little bit more impressed now. So, gotta give Google another chance to put the T in GPT. And this article is reinforcing something we've talked about multiple times on this channel, which is the death of RAG. I saw this post actually on a tweet that was like, whatever, the death of RAG, essentially, because we're just shoving stuff in context windows. So anything that reinforces my beliefs, I'm gonna read that and believe it. So let's dive in. Ingesting, also, this is from January 15th, 2025. Why did I miss this? Okay, but whatever. Chunking PDF. Converting them into neat machine-readable text chunks is a major headache for any RAG system, 1000%. It is so annoying. It's a great thing that we can all unify as developers. You say, hey dude, what's your chunking strategies? Let's complain about chunking. It's a fun thing to do with your friends. Both open source and proprietary solutions exist, but none have truly achieved the ideal combination of accuracy, scalability, and cost effectiveness. Also, and I don't want to think about this. I don't want to think about this problem. I want you to solve this problem. I want smart people to solve the problem for me. I give you PDFs, you chunk them. Existing end-to-end models struggle with non-trivial layouts found in real-world documents. Other open-source solutions usually involve invoking orchestration, multiple specialized ML models for layout detection, table parsing, and markdown conversion. A case in point is NVIDIA's NV Ingest, which requires spinning up a Kubernetes cluster with 8 services and 2 AH100 GPUs. Becomes incredibly cumbersome to orchestrate and perform, remains suboptimal. Yeah, just 2 A100s in Kubernetes and 8 services. It's okay. Also, I will say, it sucks so bad that we're on PDFs. Like, we have PDFs, guys, come on. I know you can't just do Markdown, because we need often, like, whatever, more rich representations of graphs and things like that. So, LaTeX? Should we just all go to LaTeX? Is that the move? Okay, despite their cost, many proprietary solutions still struggle with complex layouts, achieving consistent accuracy. Furthermore, the expenses become astronomical when dealing with large data sets. For our needs, parsing hundreds of millions of pages, the price tag from vendors would simply be unsustainable. Large foundation models seem like a natural fit for this task. However, they have yet to prove more cost-effective than proprietary solutions, and their subtle inconsistencies pose significant challenges for real-world use. For instance, GPT 4.0 will often generate spurious cell artifacts within tables, making it challenging to use in production. Okay, ouch. You work for Google, Sergey? You work for Google, Sergey? You're working for him right now, data scientist. Okay, CTO somewhere else. Okay, AI company. Okay. Less time reading insurance filings. Nice, going after boring. This guy's gonna be rich. All right. Doesn't work at Google, so you're allowed to. Not that we're Sama fanboys. So enter Gemini Flash 2.0. While in my opinion, developer experience with Google still lags behind OpenAI, their cost effectiveness is hard to ignore. Unlike 1.5 Flash, which had subtle inconsistencies that made it difficult to rely on production, our internal testing shows that Flash 2.0 achieved near perfect OCR accuracy while also being incredibly cheap. So look here, we got a couple examples, Gemini, but it's 2.0, 2.0 Lite, 1.5. Then we move into AWS Extract. Then we've got Gemini back for 1.5 Pro, OpenAI 4.0 Mini, Llama Parse, OpenAI, Anthropic, Reducto, Chunker. Now, the very top, the tippy top here, it says, it's got a crown on it. It says 2.0 Flashlight. It says PDF to Markdown, pages per dollar, 12,000. So the Lite, you can do more. This is 6,000. Gemini was more here, right? It was 10,000 for the 1.5 Flash versus the 2.0, and it's way more, right? Per 1,700, way better cost savings there. But this Gemini maybe is less accurate, I guess. Okay. Does this come at an expense of lower accuracy? Of all the steps in document parsing, table identification extraction is the most challenging. Complex layouts, unconventional formatting, and inconsistent data quality make reliable extraction difficult. As a result, this is a great place to evaluate performance. We use a subset of Redacto's RD table bench, which tests models against real-world challenges like poor scans, multiple language, intricate table structures, far beyond the tidy examples typically in academic benchmarks. Yeah, 100%. Everyone's like, hey guys, parse this basic PDF with the simplest thing ever. Guys, look how fast we are. We're so good. It's like, nah, dog. You need the RD. Can you pass the RD table bench? Let's look at these. Let's. Wait, we're inside of this. Can I actually see? I want to see the PDFs. Where do the PDFs exist? Download the data. Copy the download link. Okay, we won't do this now. I want a bunch of terrible PDFs. Let's see. So the results below are measured with the Needleman-Wunsch algorithm, which is what I would always use here. So you can see here we've got Reducto, Gemini, Anthropic, we've got models, we've got accuracy. So Chunker, terrible. G-Cloud, terrible. OpenAI, 4.0 Mini, 4.0, terrible. 1.5, better, but still not good. AWS Text Extract, dude, AWS Text Extract, good for you guys. You know what I mean? You're just boring, reliable service, boring name. What do? Text Extract. Let's see. Anthropic Sonnet. Damn, Sonnet. Not bad, man. I use Sonnet all the time. But now look at this. 2.0. Near perfect. Comment. Near perfect. But Reducto's the best. Why don't I want to use Reducto? Okay, so Reducto's a Harry Potter. Okay. Reducto parses complex documents, creates LLM-ready inputs with unparalleled accuracy. Interesting. I might have to use Reducto for some various work things. I'll check that out later. So crucially, let's see, Reducto's own model outperforms Gemini on this here. However, when we review lower performing examples, most discrepancies turn out to be minor structural variants. Crucially, we've seen a few instances where specific numerical values are actually misread. This suggests that most of Gemini's errors are superficial formatting choices rather than substantive inaccuracies. We attach some of these failure cases below. Beautiful elven ethereal forest. They know that I've been on this like Lord of the Rings kick, which just means every night I'm falling asleep to various Lord of the Rings videos. And now they know that I want to listen to elven music. Okay, I thought I avoided the nasty strain of, Tolkien autism, but, man, I can't stop. Okay, so Reducto's is better. There's some minor examples here. Beyond table parsing, Gemini consistently delivers near perfect accuracy across all facets of PDF to Markdown conversion, Markdown being the superior format. If you combine all these together, you're left with an indexing pipeline that is exceedingly simple, scalable, and cheap. But what if we had chunking? Markdown extraction is the first step. For documents to be effectively used in RAG pipelines, they must be split into smaller, semantically meaningful chunks. Recent studies have shown that leveraging LLMs for this task can outperform other strategies in terms of retrieval accuracy. This intuitively makes sense. LLMs excel at understanding context and identifying natural boundaries in text, making them well suited for generating semantically meaningful chunks. How do you get the chunks to put into a vector database to then pull out, to then go ask the LLM again? We use the LLM. Duh. Hey, divide this up. Great. Now let's divide it up, throw it back to the database. Now I've got a question, check the database, get the data I need, ask the LLM. Why not use the thing that's going to use the data to chunk the data? The problem is cost. It is painful. You got a million calls. And we were looking at REAG right the other night, and it was just like, hey, look how much more accurate REAG is versus RAG. Instead of using a vector database, we'll just use calling the LLM. And instead of calling one vector database call that'll take milliseconds, let's call the LLM as many times for as many documents you have. Oh, 60 documents? 60 calls to OpenAI, and just wait that time. And you're like, whoa, okay, cool. Better accuracy, but that is a lot of money, a lot of time. And I ain't got time, and I ain't got patience, and I ain't got money. Okay, I need all these things. So we can parse a 100 million page plus corpus, 100 plus million, for 5,000 with Gemini Flash 2.0, which is less than the monthly bill for several vector DB hosts. Wow. You can even imagine combining chunking with Markdown extraction based off our very limited testing. The results seem very effective. But we've lost the bounding boxes. Now, while Markdown extraction and chunking solves many problems in document parsing, they introduce a critical limitation: the loss of the bounding box information. This means users can no longer see where specific information resides in the original document. Well, hey, that was kind of at the REAG point. Instead, citations end up pointing to a generic page instead of isolated excerpts. This creates a trust gap. Bounding boxes are essential for linking extracted data back to its exact location in the source PDF, providing users with the confidence the data was not hallucinated. This is probably my biggest complaint with the overwhelming majority of chunking libraries. But there's a promising idea here. LLMs have shown remarkable spatial understanding. Check out Simon Willis' example of Gemini generating accurate bounding boxes for densely packed flock of birds. You think it could be leveraged to precisely map text to its location within a document? This was the hope of ours. Unfortunately, Gemini really struggled with this. Okay, cool. Well, hey, you got my hopes up and you let me down, but it's okay. That's actually better. They did it. It would generate wildly inaccurate bounding boxes, suggesting the document layout is underrepresented in the training data. That said, it really seems like a temporary problem. Google incorporates more document-style data during training or fine-tuning with a focus on document layouts. We could likely bridge this gap fairly easily. Lovely. Ground truth. You can see 3 distinct bounding boxes enclosing different parts of the table. Okay? Why this matters. By uniting these solutions, we've crafted an indexing pipeline that's both elegant and economical at scale. We'll be eventually open sourcing our work. Hell yeah, Sergey, you're cool now. You already were cool, but although I'm sure many others will implement similar libraries. Importantly, we want to solve 3 challenges of parsing: chunking, bounding box detection. 3 challenges of parsing: chunking, and bounding box detection. We've effectively solved document ingestion with LLMs with caveats. This progress brings us tantalizingly close to a future where document parsing is not just efficient, but practically effortless for any use case. If you haven't worked at Google and have recommendations around AI startup credits, yeah, we'd love to chat. Yeah, give me some AI credits. Hey, if you write a blog post that's gonna be popular on the internet, you might as well say, companies, give me some credits. Guys, give me a little bit of cash. So interesting, lovely. I will have to try out Gemini for myself. I will do this, and honestly, I am. Screw rag, okay? Screw rag. I need to build out some more concrete examples for myself, where I'm just doing rag versus not rag, and just doing direct comparisons. We can maybe compare them in one of these videos here. Some people I'm working for, they talk about these things you describe, like rag versus not rag. They're like, okay, it's complicated, and how much better is it? Is it really that much better? And I already need to build a system that can show differences in them. So whatever, that will be coming. But in general, it feels like this is the direction I like that we're going. All right, I don't want to have to worry about all these problems. I want someone else to handle it for me. And I also don't want to pay all this money. So I have to decide what PDFs am I going to ingest. I'm going to go to archive.org, and I'm just going to grab I'm going to be grabbing crazy PDFs from here. I'm going to be grabbing wild stuff. And give me all the PDFs. What do we got here? Just give me any PDF. Every archive.org PDF. Okay, what's this right here? Ala PDF. Yeah, I don't know what this is. Okay, Indonesian. I'm training on this. This looks good. Transcendence of Allah and acquitted the owner of the most beautiful names. Bingo. Training on that. What's this? Sumpaki PDF. Training on this. Don't know what it is. Training on it. Okay, I'm done. That's all. I'll be back tomorrow for another video. If you want to talk about anything, just, I don't know, leave a comment. Every night I'm here just trying to do a video about something in the AI space. Sometimes it's random rants from my brain because I'm working around this stuff all day. Sometimes it's a little bit of code, testing out libraries. Sometimes it's reading a white paper terribly, or what is it called, Narvix terribly. But I don't know. I'll be here every day. That's all. This is really me.